So let's do an example um, to learn more about the properties of discrete time Fourier series. So the problem statement that's given to us is to try to determine the Fourier series representation for this discrete time periodic signal. Now, one of the ways, also which has a period of 5, as you can see, so this starts from 0 and then as 5, that's the period. And therefore, we're just required to find the Fourier series coefficients over one period, which is A0 to A4. And of course, outside of this interval, the Fourier series coefficients are going to repeat themselves. So it's sufficient for us to just find these 5 coefficients. Now, one of the ways you can do this is to apply the to apply the analysis equation directly. Instead, what I'm going to use is use some existing results that we've seen already. In particular, our example that we did when we determined the Fourier series representation for a square wave in discrete time. So this signal has height 2 here for all of these indices and height 1 here for all of these instances. Now, in order to use those properties, um, I observe that this signal can actually be written as a sum of these two signals that you see on the screen. So it's this sum of the signal x1, so where this is signals x1 of n, and this signal is, which is just a DC signal, which is x2 of n. x2 of n has just a flat height of 1. X1 of n is actually a square wave, which takes on a value 1 here for from -1 to +1 time indices, and then 0 for time indices 2 and 3. Both of them, of course, have period equal to 5. So what we can see clearly is that x of n is actually equal to x1 of n plus x2 of n. So in order to use linearity, therefore, all we need to determine is to what are the Fourier series coefficients of x1 of n. So what are these? Let me say these are a sub k's. What are the Fourier series coefficients of x2 of n? Let me denote them by b sub k's. And in order to determine a sub k's, let me remind you the example that we've already done. So if you recall, when we had a square wave, of period capital N, where the square wave was equal to 1 from minus n1 to plus n1. So this height is 1. So the Fourier series coefficients were given by this expression. The particular example that we have has n1 equals plus 1 and capital N equals 5. So if you just plug in n1 equals plus 1 here and capital N equals 5 here, this is the expression that you're going to get for the Fourier series coefficients of the x signal x1 that we have over here. So from here, I know that a sub k's, which are the Fourier series coefficients for x1, are given as we just saw. They're equal to 3 by 5 for k equals 0, and they're equal to sine 3 by k by 5 divided by sine by k by 5, and of course there's a 5 here as well, which is 1 by n. These are the values of the signal, the Fourier series coefficients take for k equals 1, 2, all the way up to 4. What about bk's? That should be clear enough as well. bk corresponds to the Fourier series coefficient of a DC signal. So therefore, bk is actually equal to 1 whenever k equals 0, and is equal to 0 for k equals 1, 2, all the way up to 4. And therefore, my Fourier series coefficients for x of n, so let's say those are ck's. So x of n has Fourier series representation given by ck's. So therefore, ck is going to be equal to just the sum of this plus this. So this turns out to be equal to 1 plus 3 by 5 when k equals 0. So that's 8 by 5 when k equals 0. And for k is not equal to 0, it just takes on exactly the same form that you in a case. So this is 5 times sine pi k by 5. Get rid of this. So whenever k equals 1, 2, and go back to 4. And there you go. That's the solution. There's another way actually you can do it, and I'll encourage you to do it on your own, which is that you can try to visualize this signal as a sum once again of two periodic signals, which is one of them is this, but with a height of 2, and another one which is periodic signal which has a height of 1, but it's actually been shifted, which is a square wave which has been shifted by 2 indices to the right. And let me just leave it off as an exercise.